giving you the steps to adding and subtracting rational expressions. So again, I'll go back to that early elementary, what we did, or actually later elementary, and then we'll look at it in terms of polynomials. Or expressions, I should say. Number 1, rewrite the problem using a common denominator. If there are already common denominators, you don't need to change anything. So that's the first thing you want to look at. Number 2 is to combine the numerators and keep the common denominator. And then we're going to simplify the remaining expression. So if you think back to the first thing you would have started doing when you started doing fractions, whatever grade that is, you might have something like 3/10 plus 2/10. If it was a like denominator, the denominator stayed the same and you only changed the numerator. So you'd have 2 plus 3 or 3 plus 2 to get 5. And then the 10 would remain the same. What would you have to do next in something like this? Simplify it. So 5 over 10 would be 1/2, right? You guys remember doing that before we gave you calculators? So if you look at number 1, number 2, 3, and 4, you notice all those denominators are the same. So the only thing we're doing is combining the numerators. So looking at number 1, what is 13a plus 5a? 18a. So we get 18a on top. The denominator stays the same, so 4a squared. And then we simplify. So 18 over 4, what would that simplify to? Okay. So we would have 9 over 2. And then a over a squared, what would that simplify to? On the bottom, right? Yep. So 9 over 2a would be your final answer. So again, the denominators didn't change. We only combined those numerators.
First, I was so confused for a second because I thought the part on the side was part of that problem. And I was like,
no, this is just showing you like early
so
elementary.
where did you get 10 from?
When you're combining the exponents, how do you get just a?
It's just combining like terms. It's not multiplication where if you had 13a times 5a, then you have to multiply 13 and 5 and you get a squared.
Well, I'm just confused because it's a over a squared, so how do you get just back to a?
Oh, because we subtracted our exponents. So you have 1 minus 2, which would give you -1 in the top, and then you put it on the bottom as a positive 1. Does that make sense? All right, number 2, we have 16 in the bottom, so we know when we combine it, we're still going to have 16 in the bottom. This time we're subtracting, though, so we have to be really careful when we subtract. Make sure that you are subtracting everything. And if you have a minus in the second part, it would change to positive. So if we have 9x minus 7x, what do we get? 2. And then 12 minus 2. And then we plus 10 over 16. Now what would I do? Yeah, we're going to take out a 2 in the top. A couple ways we can do this, but I'm going to take out a 2 to get x plus 5. We have that over 16. And now what would I do? Here we go. What would that reduce to?
8, right?
Yeah, and the 8 would be in the bottom. It's going to be 1, 8. So we have x plus 5 in the top, and then 8 in the bottom.
Okay, so I jumped from the 2x plus 10 over 16 down straight to x plus 5 over 8.
I'm fine
So
with
I
that.
took a 2 out of everything.
I was thinking that. I was going back and forth, but I wanted to do something that was familiar. But if that way works better for you, please do it that way. All right, why don't you guys try numbers 3 and 4 on your own? All right, so again, we're just adding the top. So y squared stays there, so there's nothing to combine it with. 8y plus 2y would give me. And then we just have 21 at the end. Y squared minus 9 stays there, so we can go ahead and factor that. So what does y squared minus 9 factor to?
1 minus 3 and 1 plus 3.
All right, now we're going to factor the top. What did you get when you factored the top? Y plus 7, y plus 3.
Would that y squared disappear?
When we factored it, yeah.
Oh, okay.
It didn't disappear, it just factors. 3, y plus 3. And now we cancel out what is the same. We write it over here, we get y plus 7 over y minus 3 for our final answer. How'd that feel? Good? All right, number 4, we'll go ahead and do this together. The 12a minus 3 is the same, so we're going to combine the tops. What would I get if I have 1 and then minus 16a squared?
That'd be 1 minus 16.
So 1, I'm going to write it over here. 1 minus 16a squared on the top. I can go ahead and factor the 12a minus 3. How do I factor the 12a minus 3? And what do you have left?
4a minus.
Perfect.
Oh, then take the square root of the top.
Yeah, so the difference of squares, so you're getting it. So when we do the difference of squares, what would I get there?
1 minus 4a.
Yeah. Perfect. 1 plus 4a. On the bottom, we still have the 3 and the 4a minus 1.
And cross those two out, make it negative 1. So 1 plus 4a over negative 3.
I don't know where you put the negative.
Or do
So you put the negative in the bottom? I would be tempted to always just keep it in the numerator. And then I would distribute that negative 1, so I get negative 1 minus 4a over 3.
So when you combine the top, does half stay in the order? Because I did 16a squared minus 1.
That would not be correct because the negative goes with the 16.
Why did you,
The 1 would become negative.
So just the way it's written up top
Yeah,
is
yeah.
the way that, yeah.
You got it. Good question.
Because it kind of like just switched it out instead of making it the negative 1, they just canceled out like that.
So what were you left with?
I was left with 4a plus 1, which is wrong, yeah.
So how do you?
Because
I don't know why the difference in squares is just like I don't understand that.
Never mind.
Like when do you know how to do that? To square root.
If you have two terms
Uh-huh.
and there's a subtraction in the middle, if the two terms are perfect squares.
And then we have that paper with all the perfect squares on it.
Any other questions on 3 and 4 before we go on to 5? Perfect, good. All right, numbers 5 and 6, we still have common denominators. So we're going to combine the top part. But remember, this is minus. There's no n squared over in the second one, so I'm just going to rewrite n squared. Then we have 3n minus n, so what would I get? And then negative 7 minus 1. And then those denominators can be factored. So what was n squared plus n minus 6 factor to?
3 and 2, which is,
N plus 3 and then n minus 2. Okay. And now the top part we need to factor. So what would n squared minus 2n minus 8 factor to?
4, which is n plus 4 and minus 2.
I think you said it backwards. We need that 2 to be negative. So n minus 4 and n plus 2.
Wait a minute, no. N squared should be plus 2n. Because you're only subtracting 1, you aren't subtracting 5. For the first part where it goes n squared minus 2n, that should be n squared plus 2n.
No, it should, the
Thank
n
you.
should be.
That should be positive. You are right. Did you guys have positive written down? That's one of your positive or your.
Yeah.
My apologies. Yes, you were right. You're about to get me there. So that'd be plus 4. There we go.
So plus or minus 2.
Yeah, because I wrote minus 2 on accident. And now what would cancel them?
And the n minus 2.
And then we have left.
The n plus 4 and n plus 2.
Do you mess up like that to like
On
help
purpose.
us learn?
100% on purpose. Yeah. Just make sure you're paying attention. Get bonus
If
points.
one's like negative and the other one's positive, they're most likely one of them's like the same, so we just cross them out. That's
Okay,
what I did
yeah.
on the other ones. I like they were like two different, like one was positive, one was negative, but I knew they were supposed to be crossed out, so I just crossed them out anyways.
That is a good clue. Yeah.
Yeah.
Alright, now the next one. So we have 13k squared minus 9k plus k squared plus 2k. So somebody walk me through this one.
If you have the same font, you're gonna have the top secret.
Very good. What did you get?
14.
You were exactly right. So 14k squared and negative 9 plus 2. Alright, we can go ahead and factor the bottom. So we have 6k squared minus 5k plus 1. We can do the slip and slide. Now what do I do? What did you say? You would have to do the negative 2 and 3, and this one is easy to mess up on because when you have 1 and 6, 2 and 3, you can get a 5, but you have to do the 2 and the 3 because this is a negative 5. And these both have to be negative to get the positive 6. So you have to do k minus 2, k minus 3. And now what do I have to do?
Divide by 6.
So 2 over 6 would reduce to 1 over 3, right? Totally running out of room. And then 3 over 6 would be
1 over 2.
1 over 2, right?
Wait, why would it be a fraction? Like, when you
What did you
combine
put the
them?
3 in front of the K?
Very good, you will. Say that again, Cameron.
Okay, so I don't know if I've been messing this up the whole time, but I always just combine them and put like the 3 there.
You can't because that would be 6 divided by 2. So when you get the fraction, that's when you slide it back.
So if the 6 was on top and the 2 was on the bottom, then I could do that? Oh, okay. I was just making those 2 up.
Gotcha. So then I'm going to write this in the bottom. So we have 3k minus 1, 2k minus 1. What would I do to the top of this?
Take on 7.
Very good. A 7 and
Okay.
what do you have left?
2K minus 1.
Perfect. So I have the 3k minus 1, 2k minus 1.
Cross
Good. And we are left with 7k over 3k minus 1. Alright, what questions might you have on like denominators before we go on to the unlike bases?